Hello everyone, welcome back, and I hope you guys stay safe during this COVID-19 time where we need to quarantine. So today I'm gonna talk a little bit about quantum physics, and the topic that I'm gonna choose is really important in the development of modern physics. The topic that I'm gonna discuss today is about photoelectric effect. And if you're student physics like me, basically photoelectric effect is one of the fundamental topic that we learn when we take our modern physics class. And photoelectric effect is basically one of the fundamental that develop our modern physics that we use today. So why is photoelectric effect so important to the modern physics? So let's see here. So photoelectric effect is the phenomenon was fundamentally significant in the development of modern physics because of the puzzling question it raised about the nature of light particle versus wave-like behavior that were finally resolved by Albert Einstein in 1905. So basically we know that in the modern physics we know that light has two properties, that is the wave-like properties and the particle-like properties. So to prove this, we can see at the photoelectric effect, and that was resolved by Albert Einstein in 1905. So basically this is one of the fundamental topic that we learn in modern physics, that say that light has two properties, and this is why it is important in modern physics. So let's start with the definitions for the photoelectric effect. So what is happen actually with photoelectric effect when it occur? So photoelectric effect is a phenomenon in which electrically charged particles are released from or within a material when it absorbs electromagnetic radiation. So what it means is the effect is often defined as the ejections of electrons from a metal plate when lights fall on it. So basically what electromagnetic radiation is, the light. That is what it is. So the light here, it can be infrared, it can be visible light like blue light, red light, orange light, anything that visible light, or ultraviolet light, x-rays, or gamma rays. So basically for photoelectric effect to occur, it need to pass a certain frequency that is a threshold frequency. So basically every type of metal has a certain type of threshold frequency. So basically if this certain frequency cannot be achieved, which means the electron in the surface of the metal cannot escape from its bond. But if the light has higher frequency than the threshold frequency, which is the photoelectric effect can occur. So let me explain to you with a drawing. Okay, let's take a look of the idea of how the photoelectric effect occur. So the concept of photoelectric effect is when there is a metal plate. Okay, we have a metal plate. Okay, this is the metal plate, and when there is a light that shines into the metal plate, the electron inside the electron on the surface of the metal plate can escape if the light that shine into it has higher frequency than the threshold frequency of the metal plate. So this is the threshold frequency for the metal plate. So every metal type has a different type of threshold frequency. So this is the concept of how the photoelectric effect occur. So let's say we have different type of light that we use. Okay, so we're using now we're using red light as a source of light that projected to the metal plate. So let's say we use we set the threshold frequency as 5.0 5.20 times 10 the power of 14 hertz. Okay, so this is the threshold frequency for the electron on the surface of the metal that shine with the red light. So because I'm going to show you here, because we see here the frequency for the red light is 4.62 times the power of 10 power of 14. So this is the frequency for the red light. Hence, because the frequency of the red light is lower than the frequency of the threshold frequency, hence there is no electron that will escape. There is no electron that will escape from the metal plate. So it doesn't matter if you increase the intensity of the light that shine to the metal plate, there will be no electron that escape from the metal plate. So let's change the type of light that we're gonna use. So we're gonna use is the blue light. So here we have a blue light, 6.66 frequency. So let's change the type of light that we're gonna use. So the type of light that we're gonna use is the blue light. So here is the blue light. So let's say the blue light is shine into the surface of the metal. Hence, because the metal has more frequency than the threshold frequency, hence there is electron that will escape from the metal surface. This is because the frequency for the blue light is higher than the frequency for the threshold frequency for the metal. So if we increase the intensity of the light that we shine to the metal surface, the number of electron escape will also increase, because it's already fulfilled the requirement for the electron to escape, that is to be higher. The light source need to be higher than the threshold frequency. So if you increase the light intensity increase, which mean it will equal with the increase of electron escape from the surface of the metal. So this is how the concept of photoelectric effect occur. That's all from me. I hope you guys understand. Stay safe during this COVID-19. Thank you very much.